Hi everyone. Welcome back to the second lecture. This is going to be Chem with Com. So let's get started here. All right. So again, we're still on atomic structure and significant figures, but this specific topic is going to be isotopes and significant figures. Okay. So we talked about mass numbers. We talked about the symbols. We talked about the atomic number. Well, this is a kind of configuration or symbols that'll give you, yeah, some information here. Well, this atomic number we know is the number of protons. It's the number on the periodic table. This is the mass number. This is protons plus neutrons. These are the symbols. So these are kind of redundant, right? We know that helium is always 2 protons. We know magnesium is always 12 protons. But this mass number, if we subtract the number of neutrons, so 12 protons, that's going to equal the number of neutrons. But why are we even doing this, right? Well, we're going to study isotopes. Isotopes is the same element, right? Same number of protons with different numbers of neutrons. So for instance, this helium can be written as helium-4. This means it has 2 protons, 2 neutrons. This is going to be the mass number. You could also have something like helium-3. This one, helium-4, has 2 neutrons, and helium-3 would have 1 neutron. So again, isotopes, it's the same element with the same number of protons with different numbers of neutrons. And this occurs naturally. We're not forcing this. It just, we discover these and we find these in the universe and in nature. We find elements with different numbers of neutrons. Okay, so let's practice this stuff. Let's do a carbon with 6 neutrons. So carbon with 6 neutrons, right? The symbol is going to be carbon. 6 neutrons. Well, what's the atomic number for carbon? Um, how many protons does carbon have, right? So carbon has 6 protons. If it has 6 neutrons, it's going to be 12, right? And then so the top one again is the mass number, protons and neutrons. The bottom one is the atomic number, which is just the number of protons. All right. So the next one is chlorine. I'm going to do C and a kind of a cursive lowercase l. This is going to be 17 protons or atomic number. And then the mass number, if we add that to 18, that's going to be 35. All right, last one is going to be now silver. We have to might do a little bit of math here. But if you look on the periodic table, silver is Ag is silver. It's going to be 47 protons. And we have to add that to 62. So 62 is going to be the neutrons. 47 are the protons. Add that together. That's going to be 109. You could also list these as carbon 12, chlorine 35, or silver 109. All right, let's keep moving. The periodic table, I just want to show you this again because we're going to start now diving into these numbers, right? Again, we saw that this was something called atomic mass. And this is 1.008. Either again, this is going to be grams per mole or atomic mass units. But look at this. How come this one has 4 digits? This one only has 3 digits. How come this isn't, 4.00 or 4.0031379, right? It's because what we're doing is we're reporting or they're showing what are called significant figures. Significant figures are important because they tell you um, kind of what we can report, right? I can walk about a mile and I can say, hey, that's about a mile. I can't just get like estimate a mile, walk a mile and say, hey, that was 1.0000000 miles, right? Because the 1.00000 miles is more exact than around a mile, right? So those are two different types of measurements. The more significant figures you have, the more comfortable you are, or the closer that number is to the actual number, right? So it's based on the measuring device we use. It's based on the calculations we do, and that's why we report these certain numbers, right? Also, for ease of use, but sometimes the numbers are different in different periodic tables. But we're going to use a periodic table from this book for our calculations, right? So for now, we're going to figure out we're going to figure out which ones are significant figures to use and how do you tell which ones are significant? All right, so if we look at the isotopes, we have different atomic mass units, right? We have H with no protons. We have, sorry, H with no neutrons, hydrogen with 1 neutron, hydrogen with 2 neutrons. We have helium with 1 neutron, helium with 2 neutrons. So various elements have, even though they're the same element, same number of protons, they can have differing amounts of neutrons. And we're going to figure out here these significant figures. Which ones are significant or not? And typically in a science book, everything that's reported to us is going to be significant, but we have to figure out which ones are on our own. All right. Okay. Here's some rules for significant figures. Things that are significant. Anything that's not zero, right? Basically 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all significant. Zeros between non-zero numbers. Well, we know that, 1, 4, 7, there's 3 sig figs. And I might just abbreviate it as SF, right? But what about here? What about if it was 1407, right? If you look at the non-zero numbers, there's 1, 2, and 3, but then we have this 0 between the non-zero numbers, which is 4. So we have 4 sig figs now. And then we have something called the right end 0, right? That's a weird term, right end. It's anything on the right side, basically. So we have, I'll show you some right end zeros and you're gonna, yeah, we'll just get comfortable with them, right? 1, 0, 0. Those zeros are on the right. So I'm going to say right end. Oops. Right end. And I'm going to continue up here. Let's break off the page here. All right. All right. So then let's say we have 0, 1, 0. Well, these, and I'm going to call these the RE for the right end, and then LE would be left end, right? So RE, this one would be a left end 0, LE left end, right? Because it's on the left side. Let's do another one. Let's do like 1407. So this is not a right end. Not end 0. It's in the middle, right? So we don't want to count that as a right end. Let's do another one. Let's say 731.01. We'll say not right end, but 731.0. Yeah, that, yes, this is a right end zero. We could have something like, let's make it weird, right? These are not right end, and this one, yes, a right end. So anything basically at the trailing or end zeros, they can be on the right side of the number. Um, that's going to be a right end zero. Now, if you look here, it says the right end zeros are only significant if there is a decimal anywhere in the number, right? So there's three conditions: non-zeros, zeros between non-zeros, and right end zeros if there's a decimal anywhere in the number, right? Those are all significant. What's not significant is basically everything else. Now you can look through different chemistry books and people have different ways to explain this, but this is the way we're going to do it here. And it works. And so let's keep it simple and do this. Let's do another set of examples here. All right, non-zero numbers, right? 111, 3 sig figs. Non-zero numbers, 5. 1, 2, 3, 4, 5. Non-zero numbers, 1, 2, 3, 4. Cool. Zeros between non-zero numbers. So these are non-zero. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. 8. We have 3 digits. The zeros between the two non-zeros. 1, 2, 3. We have a 0 here and a 0 here. Oops, that's not right. Right? We only have 1, 2, 3, 4. So it should be 4. Now, if we had another digit over here, that would be 1, 2, 3, 4, 5, 6. All right, this other rule, right end zeros, only if there is a decimal anywhere in the number, right? Okay, so non-zeros, we have 2. These are right end zeros, but no decimal, right? So that's going to be 2. Let's do another example. What if it was 11.00? Well, since there is a decimal, it's going to be 1, 2, 3, and 4. This one, not, because those are left-hand zeros or left-end zeros. Let's try this one. 1, 2, 3, 4 for sure. We're good with 4. But we have to look at this one now. Well, we see that right end 0. Are there any decimals in the number? Right, there is a decimal. We'll say decimal, yes. So we have to include that. So it's 1, 2, 3, 4, 5. All right, this one, a bunch of left end zeros. We don't care about those. All right, so we have to figure out these. This one's for sure. This number 1 is a significant figure because it's a non-zero. Here we have a right end 0. Is there a decimal? Yep. So we'll say decimal, yes. So it's going to be now 1 and 2. So you have to look for non-zero numbers. Look for zeros between non-zero numbers, and then count the right end zeros only if there's a decimal anywhere in the number. It doesn't matter where the decimal is. It could be 15 places to the left, 15 places to the right. As long as that decimal's in the number, the right end 0 is significant. All right, let's just do some kind of weird ones. Let's do 101, right? And I'll put here sig figs. That is 3. 1010. Well, that's still 3 because this 0 is not significant because it's on the right. Let's do 1010 with a decimal. Now that is 4. 1010 decimal 1. That is going to be 5. 1010, that's going to be 7. 1, 2, 3, 4. Since there's a decimal, these 5 and then these other two zeros count, 6 and 7. Let's do that now without the decimal, right? So now we have 1, 2, 3, 4, 5. These are now right and zeros, but no decimal. So that's still only going to be 5 significant figures. All right. Let's try these. Now we're going to round. So what you do with rounding is, and it says for 2 significant figures, what I like to do is this, right? I'm going to write this pretty big, 0.424. Well, I'm going to put an X if it's significant. Sorry, if it's not significant. Not significant, 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 significant. Check mark means it's significant, right? We want 2 significant figures, so we have to cut the number off here. Now we look to the 4. So this is what we're going to keep. Well, we have to see if we need to round. And what we have to do is we want to look at the number before it. So if this is 5 or greater, we're going to round that 2 up. But if it's 4 or below, 0 to 4, we're going to keep that the same. So this is going to be 0.42. All right, let's do B now. 0.00386661. I'm going to put X's by the numbers that are not significant. Not significant, not significant, not significant. Yes, 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 yes. So we need 3 significant figures. So I'm going to say 1, 2, 3. We're going to put a line down here. And then we're going to look at, so we're going to round this one. We're not sure if we're going to round it. And then we're going to look at this one. All right, so that's 5 or above because it's a 6. So we're going to round that last significant 6 to a 7. 0.00387. All right, so we're going to write it up here. Round last sig fig up if next number is 5 or above. And there's more advanced kind of rounding rules, especially that bankers use and you do with like kind of larger data sets. But for this class, we're just going to keep it simple, and then you can add rules later on in other classes. All right, let's do another one. 421.25. These are significant, 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 significant. All right, so I'm going to put a line after the 4th sig fig, right? 4. We're gonna figure out if we have to round, so put a question mark, and this one we're gonna look. All right, so if it's 5 or above, we're gonna round that number up. So it's 421.3. Okay, D, last one, 28683.5. These are all significant. Again, we want 5 sig figs. After the 5th number, we're going to come down here. And don't forget there's a decimal there. So we're going to figure out if we need to round this, and we're going to look at this one. All right, if it's a 5 or above, you can report it as 2, 8. So we're going to round that up. 6, 8, 4. Again, there's other more kind of rounding rules for this book and for this class. We're gonna kind of skip the more advanced rules, but we're just gonna do the basics, right? The more simple stuff. Um, all right, but you could also have reported as 2, 8, 6, 8, 4. We generally do not do this because we don't want to, we kind of leave stuff out that we don't need to do. And so since these are the same, this is just extra work. We just skip it. Now, you might have to put a decimal. Let's say we wanted something for a, let's see, let's try this out. Let's say we wanted this value. Um, let's see. Let me see. I'm trying to do this on the fly. 1030.1, right? And we wanted 4 sig figs, right? Well, we cut it off here, but we can't report it as 1030 because that is 3 sig figs. We would have to keep the decimal there to show that it's 4 sig figs, right? So you want to make sure that you're doing things appropriately, and sometimes you have to leave that decimal in, even though it looks weird, right? Oops, sorry, I don't know why I circled that. Let me re-erase that, and we'll. All right, you leave the decimal in. Sorry about that, and it becomes 1030 with a period or a decimal at the end. That makes it 4 sig figs. All right. Thank you. And that's it. If you want more, you can go here. And yeah, thank you very much. And I'll catch you later.
Oh, hey, sorry, I forgot about the secret word. The secret word today for this video is princess. Thanks, and I'll see you later. Bye.